Okay, now we're getting into the bulk of these series problems. We're just given a random series and we're asked if it converges or diverges. We're not given any specific instructions and we're not told to use any specific technique. So here are a few things that you might keep in mind. The first thing you might do is quickly ask the question, does this sequence inside the series converge to 0? If the answer is no, then we're finished because the series diverges. In this case, this sequence appears to go to 0 as n goes to infinity because the denominator will go to infinity. You may not have done any alternating series yet, but if a series alternates, it'll have a term that looks something like that in it. Our series does not have that, so our series does not alternate. We'll talk more about that in future videos. The next question is, can we easily integrate this series? Can we use the integral test? The answer to me is no, we can't easily integrate that. So hopefully we can use another test that's going to work for us a little bit more quickly. And when we're looking at this series, we might be asking, do we expect the series to behave similar to some series that we already know the behavior of? For example, we already know the behavior of a p-series, and we already know the behavior of a geometric series. Well, we know that we can pull this 7 outside of a series, so that's not going to impact the convergence or divergence. We also know that as n gets really big, this 2 in the denominator has a fairly small impact on the value of each term. So we expect that this series, as far as convergence and divergence is concerned, behaves like the series for 1 over 3 to the n power. We know that that series can also be written as 1/3 to the n power. That is a geometric series with an a value that's less than 1. Therefore, this little series right here does converge. Now, we have a couple options for comparing our given series with this series that we just decided on right here. I have a tendency to use a lot of limit comparison tests, so you'll see a lot of those in future videos. So what I'm going to do in this case is I'm going to try to do a direct comparison. I'm going to pull the 7 outside, and to do this, we see that this sequence, 1 over 2 plus 3 to the n, is less than or equal to 1 over 3 to the n. The reason that is because this 2 right here makes the denominator on the left side bigger, therefore the left side is smaller. And actually, this is all the information we need. We already know that the series of this right-hand side converges because it's a geometric series with a less than 1. Therefore, we automatically know that this series right here converges because it's smaller than a series that we already know converges. And finally, if we refer back to the original series, we know that our original series converges as well because just multiplying a series by a constant doesn't change whether or not a series converges. Okay, we use the direct comparison test to do this problem. I think we should use the limit comparison test in the next video. Let's go check it out.